Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Today we are today lecture is class 9th, subject physics. Topic of today's lecture are 4.7 and 4.8, which are on pages covered with the pages which we will cover today, 96, 97, 98, 98 and 99 of your 9th class textbook. Today's topic is couple, 4.7 couple, which is on page number 96 of your 9th class textbook. Before starting a couple, I will give you the couple is same like torque as we discussed torque. In torque, definition of torque is turning effect of a force is called torque, but in couple we'll talk about in torque can be in one way, but in couple the torque will be produced in two forces will be applied, one over here and one other here. These forces are unlike forces, because why I'm saying because I have told you about like forces and unlike forces as well. Like forces are the forces which have parallel to each other and have same direction. But unlike parallel forces are those forces which are parallel but opposite in direction. So the definition of couple is a couple is formed actually. Definition of couple: a couple is formed by two unlike parallel forces of the same magnitude but not along the same line. What does this mean? Unlike parallel forces, first of all, you should be very much clear. In couple, we have two unlike forces. Why I'm saying unlike forces? Because one is the direction of one force is upward. See the arrow is pointing upward, and see the arrow downward, the arrow is pointing downward. So these are unlike parallel forces. These forces are equal in magnitude. They are equal in magnitude. Magnitude means if it is 2 Newton, then this will be of 2 Newton as well. But its direction will be opposite to this force. If it is upward direction, this will be in downward direction. If it is so, in so definition of a couple is formed by two unlike parallel forces of the same magnitude but not along the same line. Same line. If it is the same line, they must be in equal magnitude or equal direction. But I am talking about unlike parallel forces. So in couple we have two unlike parallel forces, one upward and one downward. So if you take the example of the car steering, so what will happen when we turn our car? What will happen? We move our steering. We move our steering to turn the car. What will happen? One force, we apply the one force on right hand upward direction and one in the downward direction. So car steering is the best example of the couple. So what is this? This point is called O point. So this is the moment arm. This is the moment arm for this force, and this is the moment arm for this force. So you got to remember that couple produced by two unlike parallel forces. Unlike when the term unlike parallel forces comes, it means the forces are parallel but they are in opposite direction. Example, we consider the example now of the couple. When a driver turns a vehicle, he applies the forces that produce torque. The torque turns the steering wheel. These forces act on opposite side of the steering wheel. Look, one opposite side of the steering wheel, one upward and one downward, are equal in magnitude but opposite in direction. Its direction is upward, its direction is downward. But if it is 2 Newton, this will be 2 Newton. They have the same magnitude but opposite in direction. So these two forces form a couple. If I take the second example of the couple, what will happen? We have this is figure A, which is steering wheel. This is steering wheel. Figure B is double arm spanner. This is our double arm spanner. So I'm talking about taking the example of the couple. Second example of the couple, which is called um, steering. Sorry, if we okay. If we talk about, we were talking about here from here. So if I talk about the double arm spanner, in double arm spanner is used to open or close the nut. You might have seen the people who puncture who puncture our car, who take the puncture of our car. They use this double arm spanner to open or close the nut, or to open or close the nut of the car wheel. What happened? Double arm. Why it is called double arm? Because this is one arm and this is second arm. So double arm spanner is used to open a nut, or it can be used to close the nut. There are two forces act on the spanner. One force is acting upward. If I sorry, it is getting okay. So one force is acting upward in this direction, and one force is acting downward. Suppose on double arm spanner we have 3 points. One is A point. This one is A point. This is our A point. A point is down here, and this is our B point, and this is our O point, which is over here. So we have double arm spanner. One force is acting upward and one force is acting downward direction. If we want to open the nut, what will we do? We will move this double arm spanner in anti-clockwise direction to open the nut. So there are the two forces act on the spanner that are equal in magnitude but opposite direction. Their direction is different. One direction is upward and one direction is downward, but they will be of same magnitude. Magnitude, if it is 2 Newton force, this force will be of 2 Newton as well. So total torque of the couple will produce, okay. The torque will, because the spanner, if we talk about the couple, we are talking about two torques. So one torque is produced with this F multiplied by OA. This because the definition of torque is force into moment arm, F cross L. So F multiplied by moment arm is OA plus. So F, this is F and this is OB, plus F multiply. This is multiply sign. So F multiplied by OA plus F multiplied by OB. If we take F common, what will happen? This will be OA plus OB. Since OA plus OB is totally equals to AB, this distance AB, OA plus OB is equals to total this type of distance. If I consider taking this shape and use this one, so OAB, AB is like total distance, this distance from this point to this point. So F is equal to, if I take F common from this one, so OA plus OB, and OA plus OB equals to total distance AB. This one is AB. From this point to this point is distance AB. So F cross AB. So equation, this is equation number 4.8 on page number 96 under the couple topic couple. Equation 4.8 gives the torque produced by the couple of forces F and F separated by a distance AB. The torque of a couple is given by the product of, because there is a multiplication between force and the distance displacement, product of one of the two forces and the perpendicular distance between them. Why I'm saying this is a perpendicular distance? Because force is acting upward and this is the perpendicular. So force and OAB are perpendicular to each other. So so total torque of the couple produce F, product of force and the perpendicular distance AB. So this force and this force AB are making 90-degree angles. So they are making 90-degree angles. So this is the end of the topic couple. I repeat this article for you, student. What we did discuss now, we discussed about couple, and we talked about torque as well. Torque is basically the turning effect of a force. But when we talk about the couple, so in couple we have two forces acts. They will be of unlike parallel forces, and because why I'm saying unlike parallel forces, because they have same magnitude but opposite in direction. Whenever I'm talking about unlike parallel forces, it means they have same magnitude but opposite in direction. So in couple, we talk about this force and this force are same in magnitude but opposite in direction. Its direction is upward and its direction is downward. So the couple best example is car steering wheel is the best example. When we take the turn, we use the car steering wheel, we are producing the couple. So we are moving our car steering wheel in anti-clockwise direction because we want to take the left turn. If we want to take the left turn, the one force over our hand is acting upward and one force over our hand is acting downward. So they will produce the couple. So the other example of double arm spanner is another example of our couple. In double arm spanner, it is used to open or close the nut very easily because it is a double arm spanner. So some force will be applied on this side. Our one hand is on this side, and our one right hand is on this side, and our left hand is on this side. So when we apply the force, this is used to open or close the nut of the car wheel. You might have seen this double arm spanner with the mechanics who use it for to make punctures of the car wheels. There are two forces act on the spanner that are equal in magnitude but opposite in direction. One is acting upward and one is acting downward. So total torque of the couple will be produced F multiplied by this OA plus F multiplied by OB. So if I take F common, so OA plus OB equals to, if I take F common, so OA plus OB equals to OA plus OB equals to total AB, this one. So I can write OA plus OB equals to AB, this one, AB. So our total torque of a couple will be produced product of force and the perpendicular distance, this product of force and the perpendicular distance. So this is end of our couple definition and examples of the couple. Now I'm moving towards next topic, which is 4.8 on page number 97 of 9th class textbook. What is actually equilibrium? The definition, first of all, I will explain you the definition of the equilibrium. A body is said to be in equilibrium if no net force acts on it. Right. What does this mean? If there is a no force act on the body, it means the body will be on equilibrium. If I take the example, the book lying on the table, because the book is at rest, the book is not moving. So this is another example, the body is at equilibrium. The picture hanging on the wall, because the picture hanging on the wall is not moving, so it is at rest, so the body is in equilibrium. Next, I will talk about, according to the first law of motion, the first law states that whenever the body is at rest, it tries to remain at rest, and when it is moving with uniform velocity or uniform in a straight line, so it will be keep on moving if no external force acts on. So if there is a no external force acts on it, it means the body will be in equilibrium position. For example, I gave you the example of the book lying on the table. The book lying on the table. Look. In this case, the book lying on the table. Book is at rest. So book lying on the table is its weight acting down. In book lying on, if in the example of book lying on the table, the weight of the book is acting downward direction, and while the normal direction of the table, the force which a table is applying on the book is upward direction. So these two forces, weight and the normal reaction, are equal in magnitude. So they will cancel the effect of each other. The body will be at rest, or we say the body will be at balanced, and we say the body is in equilibrium position. Okay, if we take the example of wooden log. Wooden log is a piece of wood. Suppose this piece of wood is supported with two ropes. This is one rope, F1. Rope 1 force is F1. Rope 2 force is F2. The weight of the this wooden box is lying downward. Weight is, weight of the body is always lies downward. So weight is acting downward, while the two forces are F1 and F2 are supporting this wooden log. What will happen? The resultant of these two forces, like F1 and F2, which are moving upward, they are balanced by the weight of the log, which is acting downward. So our wooden box will be at rest, or we say this is in equilibrium position. So this is the example of now if I take the example of, as we discussed, so images of the objects moving with uniform velocity are in equilibrium. The objects which are suppose we have a car which is moving on the leveled road. Level road means smooth road. There is no bumps on the roads. If the car is moving on the smooth road or leveled road, it is moving with a uniform velocity. The uniform velocity is defined if the displacement of the body is not changing with respect to time, and body covers equal displacement in equal interval of time, then the velocity of the body will be uniform velocity. Uniform velocity means if one displacement cover in 2 seconds, the other displacement of 1 kilometer if the body covers one kilometer displacement in 2 minutes, then other 1 kilometer displacement in 2 minutes, then we will say the body is covering uniform moving with the uniform velocity. If the body is in uniform velocity, we will on the leveled road and there are no bumps in the roads, then the body will be also in equilibrium position. Now, we will consider the aeroplane and plane flying with uniform velocity in air is also in equilibrium because it is covering equal displacement in equal interval of time. That's why the body is said to be in equilibrium. So we discussed about the bodies which are at rest. These are the bodies which are these book and frame. A frame of picture and wooden log, these bodies are at rest, they will be in equilibrium position. Similarly, the bodies which are moving in on a leveled road or aeroplane flying in the air, since they are moving, but they are moving in the uniform velocity. So these in air, so these will also be called in equilibrium position. Next, we will discuss about conditions of equilibrium. We talked about where the bodies will be equilibrium, but now we will talk about first condition. There are the two conditions of equilibrium. One is called first condition of equilibrium, and the other is called second condition of equilibrium. What I am talking about, what is the first condition of equilibrium and second condition of equilibrium? So if the body is in equilibrium, it must satisfy, the body which is in equilibrium must satisfy these two conditions. If any of these two conditions are not satisfied, then we will not say that the body is in equilibrium position. For example, first I am talking about first condition of equilibrium. For a body in equilibrium, it must satisfy two conditions. A body is the first. What is the first condition of equilibrium? A body is said to be satisfied first condition of equilibrium if the resultant of all the forces acting on it is zero. The resultant of all the forces the forces which are acting in x direction, or the forces which are acting in y direction. These all the forces will be equals to 0. The x direction forces will all the sum. This is the sigma sign with Greek letter, which means summation. This all thing can be written this thing, and this all thing can be written this way. If this is called summation of Greek sign, which means summation fx equals to 0, it means all the forces acting, it means all the forces acting in x direction must be equal if we want to first condition of equilibrium want to be true. Next, all the vertical forces which are acting vertically equal to 0. So it means first condition will be satisfied if all the forces fx equal to 0, all the forces in x direction and all the forces in y direction must be equal to 0. The book lying on the table, it's mean the book lying on the table is the example that all the x direction forces and the y x direction forces acting on the books are equals to 0. Where sigma is the Greek letter called sigma used for summation. Summation, whenever the letter summation comes, it's mean plus sign. Okay. Then second condition of equilibrium. What is second condition of equilibrium? The summation of all the torque acting on the body must be 0. You know the body can rotate as well. So this is also uh, for the body to be satisfy second condition of equilibrium. The forces which can cause the body to rotate, this will be called torque. But if the body is in equilibrium, this means all the torque summation of all the torques produces equal must be 0. So if these two conditions will satisfy, then we will say the body is in equilibrium position. A body satisfies second condition of equilibrium when the resultant torque acting on it is 0. Resultant torque means summation T1 tau 1 plus tau 2 plus tau 3 equals to 0. Summation tau equals to 0. So if the body is satisfying, if the body is in equilibrium, it must satisfy these two conditions. A ceiling fan rotating at constant ceiling fan rotating at constant speed is in equilibrium as net torque acting on it is 0. It means if the ceiling fan, this is the example of ceiling fan, this is also available in your text 9th class textbook. So if the ceiling fan is moving, rotating, it's mean it is in equilibrium as it is moving in the uniform speed. As we discussed in this example, and we discussed this one, this is satisfying first condition of equilibrium, and second condition of equilibrium. This is also satisfying first and second condition of equilibrium. So body will be in equilibrium position if or sum of all the forces acting clockwise direction, x direction, or y direction equal to 0, or sum of all the torques acting on the body is 0, then the body is said to be in equilibrium position. Now, guys, I repeat all the whole topic for you again. Today, what we discussed. Today we discussed the topic of today's lecture was 4.7 and 4.8. We discussed, we talked about couple, and then we talked about equilibrium. Pages we cover today of your textbook, 9th class textbook, 96, 97, 98, and 99. So first of all, we discussed about couple. What is called couple? Couple is similar to torque. Torque is a turning effect of a force is called torque. But in couple, there are the two forces acting on the couple. One is upward direction and one is downward direction. It's mean this. If we take the example, the best example of the couple is car steering wheel. When we take a right turn or left turn, what will happen? We are moving the car steering wheel towards. If we are moving this left hand, if we're taking the left hand turn, we are moving the car, our steering wheel on the left hand side. So couple will be produced because our one hand is acting upward direction and our lower hand, our left hand is acting downward direction. So whenever there are the two forces acting on the body, they will produce because they are turning the effect. they are turning the wheel because torque is basically a turning effect. So there are the two torques produced in this direction. So one upward and and these forces are unlike parallel forces. Why I am saying unlike parallel forces? Because they are acting on the board. One is force acting upward and one force is acting downward. It means they are parallel, but their direction is different. Unlike parallel forces, these forces are unlike parallel forces. So I discussed about the drivers. When a driver turns a vehicle, he applies forces that produce torque. The torque turns the steering wheel. These forces act on opposite sides of the steering wheel, are equal in magnitude but opposite in direction. So their direction is different. But if it is 2 Newton, this will be of 2 Newton. Magnitude will be same. Double arm spanner. We talked about the second example of the couple, which is a double arm spanner. This the one force is applied. This is used to open or close the nut. One force is applied in upward direction, and one force is applied downward direction. So the total torque produced in this case, the F cross OA and F cross OB. So if you take F common from these two, so what will be left? OA in the bracket, OA plus OB will be, OB will be left. So F cross, if OA and OB is equals to total AB. So we can write OA plus OB equals to AB. Then this is the end of the, so torque couple is basically product of force and the perpendicular displacement. So this is a force and this is a perpendicular displacement. So they must be making angles 90 degrees. Then we discussed about equilibrium. A body is said to be in equilibrium if no net force acts on it. According to the first law of motion, the first law of motion tells us that a body continues state of rest or uniform motion in a straight line if no net force acts on it. So it's mean body continuous states of rest. It's mean continuous state of rest means the book lying on the table and the log. Log are the example of body at rest, or the uniform if the bodies are moving with the in a straight line on a net force acts on it. Example. This is also the state of equilibrium definition we discussed as we discussed in this example. So in this case the bodies are moving with uniform velocity, but in this case the bodies are at rest. In both cases, bodies are in equilibrium position. We discussed about when we discussed about book. So there are the two forces acting on it. The weight of the book is acting downward, while the reaction of the book or reaction of the table is acting, or normal reaction. Normal reaction is particularly denoted with capital R. It is acting upward. So these two are cancelling the effect of each other. So they are anti-parallel. So they are balanced, they are in equilibrium. In this case, two ropes, there are the two ropes. One is acting upward, one is acting, they are holding the rope. So that the total resultant force are balanced by the weight of the body, weight of the log. So then we discussed about the body which are moving with uniform velocity. They are also in equilibrium position. Then we discussed about two conditions of equilibrium. The body must satisfy two conditions of body if the body is in equilibrium. Sum of all the forces in x direction and y direction must be equal to 0, and sum of all the torques producing must be equal to 0. Now, students, we have the homework. You must study, read, and study, and you got to memorize the definition of equilibrium. Homework is definition of equilibrium. You need to memorize the definition of equilibrium. Then you must consider the examples. What are the examples of the equilibrium? And you read it, write it as much as you can, so in order to understand this topic completely. I hope you guys understand all this topic very much. If you have any problem then or understanding this one, please let me know.